3 matrices, determinants, and inverses. We go straight into finding the determinant of a 3 by 3. I'm going to show you how to do this on a calculator, but first you will have to do this by hand. It's very similar to finding the determinant of a 2 by 2. Do not pay attention to the method they use in the book. This method is a lot easier. All you do is you use the first row of numbers. I use the -1, the 3, and the 5. And with those first numbers, you must alternate signs. Okay, so you keep this sign the same. You change this to a -3, and you keep this as a +5 in your first step. So you must remember this rule.
What if it's
keep,
like,
change, keep. Yes.
so if it was -1, 3, 5.
It is
or
-1,
3, -5.
This becomes -5 at the end. You just keep this. These first and last, you keep the original sign. The middle one you change.
Where are you getting those 2 by 2s from?
I'm going to show you. Okay, so what you do. So that's how I get these first numbers. This is how I'm finding the determinant of a 3 by 3. So what you do with the -1, you cross out the column and row associated with the -1. And what are you left with? A 2 by 2. So we're going to find the determinant of the remaining 2 by 2. -4, 6, 1, -1. I do that straight across. So with 3, I cross out the column and row associated with it. And what are you left with?
2,
6, 0, -1. That's where I get this one from.
Okie dokie.
And the last one, cross out the row and column, you're left with 2, -4, 0, 1, and go from there. We know how to find the determinant of 2 by 2s. Okay, multiply diagonally. What's -4 times -1? 4. 4 minus 6, -2. Okay, and just go straight across. -2 minus 0 is -2, and 2 minus 0 is 2. So simplify this to 2 plus 6 plus 10 equals 18. Okay? And I'll show you in a second how to do that on the calculator. Yes, ma'am.
So you really didn't change the number 3 sign, so just remember the formula that's in red?
What?
So even though you have -3 down here, you really didn't change that to a negative, but just leave the, whatever the formula is in red, just follow that?
Right. Because the 3 was positive up here. So you had to change it to a negative here. Because it's plus, minus, plus. Always follow. Don't be the person to forget this pattern. It's always plus, minus, plus. Okay?
But how would it be plus minus? Sorry, how would it be plus minus plus if you
Because
didn't
it was
change
originally a +3. I changed it to a -3.
I know, but if you're trying to keep the sign to the -1.
I did keep the sign of the -1. And I kept the sign of the 5. I changed the sign of the 3.
But it says to do plus.
Yeah.
So when
No,
you
it
change
doesn't.
to a positive,
It says to do a minus for the 3.
No, but for the negative
for the
one.
The plus means keep the sign the same.
Well, then how about you just put
Keep.
change, keep?
I said it. Keep,
That's
change,
like
keep.
9 letters to it.
Okay? Keep, change, keep. Okay?
Yeah, it's good.
Smoking looks delicious.
No, it's good. It was delicious, wasn't it?
Alright. Now, verifying inverses.
Oh,
Oh my God.
In this example, they tell you that the 2 matrices are inverses. You have to prove it. So, in order to prove 2 matrices are inverses of each other, you multiply them together, and you must end up with the what?
Identity problem.
Identity matrix. Okay? So when I multiply those 2 together, you know how to multiply matrices, and you're going to have to do this. Show me all the steps, and there are the steps right there. Okay? To get the first row of entries, I use the first row with the first 3 columns, or the 3 columns of the second matrix. Okay? This is not new. You know how to multiply 2 matrices. You take the rows of the first, columns of the second. But to show that they're inverses, you must end up with the identity, which we do in this case. This is the identity matrix.
Are we gonna have
So you have to do
windows on
1
the
times
non-calculator section?
You will have to do that on the non-calculator section. Because all it is matrix multiplication. Okay? What? Okay?
Can you leave that up for a while?
I'll leave that up for a minute. All right, while you're writing that down, it's easy to verify whether they're inverses. We've already talked about that. You will not have to find the inverse of a 3 by 3 by hand. I'm going to show you on the calculator how to find the inverse of a 3 by 3. You know how to find the inverse of a 2 by 2. That's where we did 1 over the determinant and times the switching of the A and D, negating B and C. Remember that? You don't have to do that here. So if I gave you this matrix and told you to find its inverse, you must use the calculator.
I thought you said that it was going to be on the non-calculator.
This type of question itself will be on the non-calculator part. If I give you 2 matrices and tell you to verify their inverses, all you do is multiply them together. But if I just give you 1 matrix, you must use the calculator to find its inverse. Okay, can I get rid of this yet?
Almost.
All right, I'll come back to it.
Alright.
All right, so the next example, we have a matrix equation. We had these in the last section. Matrix A times matrix X equals matrix B. Anything in this form, you must solve it by doing A inverse B. That should look familiar. But again, we can't find the inverse, or we're not going to find the inverse of a 3 by 3 without the use of a calculator. You have to use your calculator on this part. So get out your calculator. And we're going to do that problem in the calculator. Everybody ready? So, you hit second matrix. Well, let's clear that out. Hold on a second. I'm going to clear this screen. Hit second matrix. We're going to edit the first one. So go over to edit and hit enter. And it's a 3 by 3. So hit 3 enter, and there are your entries. 0, 0, 2, 1, 3, negative 2, 1, negative 2, 1. Yeah, once you're ready, once you type that one in, who's not finished with that one? Okay, now go hit second matrix and go over to edit. And the second one was a 3 by 1. So hit enter. And hit 3 enter, 1 enter, 6, negative 11, 8. Okay, now to solve the equation, get a blank screen, so hit second mode. And we're going to do second matrix 1, and the inverse button is right here in red. Okay, so you get a little negative 1 as an exponent. Okay, and then second matrix 2.
Inverse?
No,
Okay.
just inverse of the first one.
How'd you do the first one?
Which part?
How'd you invert one?
The inverse button is right here. Okay, so you hit second matrix 1, inverse, second matrix 2, enter. And you should get 1, negative 2, 3. Did everybody get 1, negative 2, 3? Okay,
Yeah.
now That's all you have to do to solve the matrix equations that have 3 by 3s. Alright, involving inverses. Now let me show you real quick how to find the determinant of any matrix. Let's just find the determinant of matrix A. Okay. And again, you're still going to have to do this by hand on the calculator.
You're not gonna make us have to find like 5 determinants of a 3 by 3.
Wait, you said we're gonna.
So that would take a long time.
5 determinants of a 3 by 3.
Like, we're not gonna have to do this 5 times on the test.
Oh, probably not, no. So hit second matrix, go over to math, and the first selection is DET, that stands for determinant. Hit enter, and let's find the determinant of the matrix we just plugged in. Second matrix, 1, enter, and there's the determinant of the 3 by 3 that we just did. Okay, so you know how to find the determinant and the inverse.